Welcome back to Release Radar. I'm Chris Biscardi, and today we're talking about what 55,000 lines of Rust gets you. Our story starts with this issue, number 2181, on the RR project, called The Merits of Implementing RR in Rust. As an open source maintainer myself, typically what happens after somebody opens an issue like this is there's some discussion and then the issue is closed and doesn't get rewritten in some other language, and everybody moves on. But that's not what happened here. Siddharth, the author of the issue, went through some conversation with the other maintainers, and then actually wrote 55,000 lines of Rust to port RR to Rust, resulting in RD. Both RR and RD are what are called debuggers, and the act of debugging a program is the process of finding and resolving bugs in that program. There are many ways to figure out what went wrong with the execution of a program. Writing console log or print line is an extremely common approach, and we can also consider methodologies like writing tests, reading structured logs, or querying distributed traces to be debugging patterns. When you have a problem with your program, what's your preferred way to figure out where the problem is? Let me know in the comments. The approach we're talking about today is interactive debugging using a tool called a debugger. But debuggers have a usability problem. They're often thought of as arcane or hard to set up, and once you've got them set up, it can be hard to actually use them. If you step too far through your program accidentally, you have to restart your entire debugging session and reproduce the bug again. In the author of RD's opinion, debuggers are just as interesting as compilers and other programs, except they haven't received the revolution that compiler design and implementation has over the last few decades. For example, in my own experience, even the JavaScript ecosystem uses compilers for all sorts of things these days, but few JavaScript developers use debuggers. The author of RD additionally sees what LLVM has done for new languages, allowing the dirty bits to be in LLVM, which affords new language designers the ability to focus on their language rather than those dirty bits, and wishes for that to happen for the world of debuggers. So what are the problems with debuggers? Well, debuggers are plagued by non-determinism in the subject of the debugging, our programs. Bugs in said programs can be the sorts of bugs that appear once in 1,000 program runs, or worse. Resolving this problem is the domain of record and replay, where if you can record the problematic program execution, then you can reliably replay it, showing the bug. If you're familiar with Redux in the JavaScript ecosystem, record and replay debuggers are very similar to the ecosystem of time travel debugging tools that have sprung up around Redux, but applied to wholly more complex programs like the entirety of Firefox. Which brings us back to what is RD. RD is a lightweight tool for recording, replaying, and debugging the execution of applications, which are trees of processes and threads. It's a port of RR to Rust, so what you read on rrproject.org generally applies to RD as well. RR and RD are a layer on top of debugging tools like GDB, enhancing your debugging experience by providing a platform. So it's nice to have tools, but when would you actually use a debugger like RD with record and replay? So imagine you have a piece of code that malfunctions once in every 1,000 runs. This could be a flaky test or running the program itself. If you can capture that special run using a record and replay debugger, then you can consistently and deterministically replay that program right down to the syscalls to isolate the problem. This is quite a difference because if you're only using print lines to debug, you will have to run your program approximately 1,000 times to reproduce that bug once. RD can only be used on 64-bit Linux operating systems running on Intel hardware. AMD is not currently supported. However, it is supported in RR, so if you need wider platform support, RR would be what you use today. Which begs the question, why rewrite RR in Rust anyway? Rewrites are gigantic pieces of work with plenty of opportunity to introduce new bugs that didn't exist in the original program. So why take on a 55,000 line and continuing project rewriting RR in Rust? In the author's own words, rewriting RR in Rust is one possible way to deal with the ever-growing complexity of the Linux kernel APIs, as well as the RR project itself. In this case, the Rust language provides language features that make writing reliable code easier and the ability to perform refactoring with confidence. Another major reason for the rewrite was to reduce the barriers to understanding and contribution, the author believing that Rust is an easier language to grok than C and C++. Personally, I have to agree here and add that the Rust language is far more welcoming, which is a result from the amazing efforts of the Rust language maintainers. The error messages you get from the Rust compiler, for example, far exceed most other languages that I'm familiar with. Finally, RD is meant to be a platform for future experimentation in the record and replay debugging style. For example, one could take advantage of a print line debugging approach in addition to using a record and replay approach, resulting in the ability to add logs to a program after the program has executed, even if the bug only shows up every 1 in 1,000 runs. Overall, RD is not what I'd call a hard fork at all. It's more of a friendly fork that intends to coexist with RR in a way that promotes the growth of both projects. While RR and RD are layers on top of programs like GDB, LLDB can also be used to debug Rust code today, and is the default debugger in Xcode on macOS. If you're just getting started on your journey to debugging Rust code, VS Code LLDB is a good place to start. And the Code LLDB extension for VS Code does have experimental support for reverse debugging, also known as time travel debugging, which is exactly what RR does. Finally, if you haven't experimented with debuggers in the past, I encourage you to in the future. Even though many of the debuggers that are available today may not have the best user experience, there are newer debuggers coming out like RR and RD that provide better user experiences and enable you to work on a much deeper level with your code. I would also say that using a debugger is typically reserved for these more complicated issues, and that if you can solve your problem with print line debugging or console logging, that's fine as well. Knowing debuggers is very useful with a class of problems that happen once in a while that are hard to replicate.